Welcome, dear students. Welcome to another session of our lecture on renewable energy. I hope all of you are enjoying my lectures. Please comment your valuable feedbacks and suggestions, and you can also specify in the comment box the demand for the videos on which subject would you like to have the new lecture. So please do that also. If you are enjoying my videos, please don't forget to subscribe. So I have videos on renewable energy, internal combustion engines and fluid power as of now, and I have planned for other streams in mechanical engineering, especially under thermal engineering stream. So today we are going to see the features, generation and pros and cons of solar energy. Even though it looks very simple, but there are so much of technical terms and reactions taking place behind the generation of solar radiation which we are receiving freely on the surface of Earth. So straight away we will move on to the lecture. So Thomas Alva Edison had told during his time, I put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that. So he had that idea, who invented the electric bulb. He had the idea to get energy or utilize solar energy as a renewable energy source. Now still in our age also we are improving the technologies, or we are not able to trap the entire solar energy which is freely available on the surface of Earth. Still there are lot of scope for improvements in the design of the systems which convert solar energy into electricity or any other useful form of energy. So let us see some overview of the solar energy, how that term coined to the common people from the era of oil crisis. In 1970s, you know that there was energy crisis, oil crisis. So that was the reason the blatant obviousness of the problem was waned. But the underlying technical and political problems have not been disappeared till now. Till 2020, after 50 years of time, still there are so much of technical problems existing in the conversion. So you may be able to collect the energy, but storage as well as a better efficiency systems to convert solar energy into useful form is still in the developmental stage or research stage. So despite major efforts towards improving the efficiency of energy consumption, the overall per capita use of energy continues to increase. So even though our resources are getting depleted, still the energy consumption per capita is on the verge of increase. A frequently mentioned solution to the problem of increasing requirements of energy and dwindling energy sources is to tap the energy in sunlight. Almost all the areas on the Earth are receiving solar energy at least on a better basis. I mean, the energy intensity at least for 6 hours a day around the year. This is photograph of a home in California in 1906. In 1906, much before the year of oil crisis. So there you can see a solar collector on the top of the, on the roof of the house. So still the people were using this. That time itself, people were using the solar energy. You see that. Now how this solar energy is generated, that is what we are going to see now. So you can see here, inside the sun globe, the hydrogen isotopes deuterium and tritium combine together to form helium nuclei plus a neutron plus some form of energy. So this energy is available for us for utilization. So you can see here deuterium and tritium isotopes are combining together to form helium nuclei, and neutron plus some energy will be released. Helium nuclei plus neutron plus energy will be released along with this. So if you write down the reaction, chemical reaction, you can see here a balanced chemical reaction. 4H will give you 2He plus this amount of energy. This much amount of energy, that is 26.7 million electron volts. 26.7 million electron volts of energy is obtained from a single nuclear fusion reaction between deuterium and tritium. So if you write down the mass of 4 hydrogen atom, that is deuterium tritium, it will be approximately 4.0304 mass units, which will give you the mass unit for the corresponding helium is 4.0027. You can see here there is a difference. The product and the reactant are having the energy difference. So the product is having a lesser mass when compared to the reactant. That means the difference between these two is released as energy, and as per this law, what is this? E is equal to mc square. That is, all of you have studied that, right? All of you have studied that. So that is, have you got it? E equal to mc square is the theory proposed by Albert Einstein, right? This is a special equivalence theory between energy and mass. Okay, so using that, this mass difference is converted to energy. So you can see here 26.7 million electron volts of energy is released from a nuclear fusion reaction that is taking place inside the sun. What is solar energy? So we have seen that this energy is originated with the thermonuclear fusion reactions occurring inside the sun. Solar energy represents the entire electromagnetic radiation, visible light, infrared, ultraviolet, X-rays and radio waves. So it represents the entire electromagnetic spectrum, which we will be discussing later, the spectrum and all. So solar energy travels from the surface of the sun to the surface of the earth in the form of electromagnetic radiation. So radiation is one form of heat transfer apart from conduction and convection. The advantage of radiation is there is no loss, and the heat transfer will be in its highest degree among conduction, convection and radiation. The heat transferred in the form of radiation is of the order of temperature to the power 4. Okay. So that heat transfer, modes of heat transfer and all we will cover in another session. Modes of heat transfer, the fundamental laws like Fourier's law of heat conduction, Newton's law of cooling, Kirchhoff's law and Stefan-Boltzmann law of radiation. That we will cover in another session. Okay. So that will be clear to you if you have any doubts on that. So there are many forms of electromagnetic radiation, such as ultrasonic waves. You might have heard ultrasonic, right? Ultrasonic scan, you might be familiar with. So there we use ultrasonic waves. So it is one form of waves in the electromagnetic spectrum. Then radio waves, infrared, visible light, ultraviolet. Have you heard that? Ultraviolet? Ultraviolet, UV index, you might have heard in the weather forecast, UV index. So if UV is greater than 10 on a particular day, at a particular period of time, if that solar radiation falls on our skin, it will cause damage to our skin. Sunburn may happen. So it is better to avoid outdoor activities when the UV index is pretty high, especially if it is greater than 10. On usual days, the UV index in our country will be of the order of, during summer it may go even up to 11 or 12, but during other period of time it is usually of the order of 5 to 7, 8, like that. That is manageable for us because we have started traveling under the sun only, from our childhood days under the sun for these conditions. So our body is built for these conditions. So up to 7, 8 or even 9 will not cause any damage to our skin. Then X-rays, gamma rays and cosmic rays. So all these are different forms of electromagnetic radiation. So these different forms of electromagnetic radiation are all characterized by their wavelength and frequency. Right? Wavelength and frequency are the two characteristics of these different types of waveforms in the electromagnetic spectrum. So all electromagnetic radiation travels at the speed of the light, c. You know that c is the speed of light. So the product of wavelength and frequency, this lambda is the wavelength and mu is the frequency. The product of these two is equal to the speed of light. Now let us look at the characteristics of the sun. It is a hot gaseous sphere. Sun contains gaseous matter and it is in the spherical form. It is having a mass of 1.991 into 10 to the power 30 kilograms. Almost 2 into 10 to the power 30 kilograms and having a radius of 6.96 into 10 to the power 8 meters and with an average density. Density is varying from the core of the sun towards the surface. Okay, so average density is 1.41 gram per cc. And the sun is having the surface temperature of 5762. The core temperature will be pretty much higher than this, but the surface temperature itself is 5762 Kelvin. Can you imagine such a large value of temperature? So 90% of the energy generated as a result of nuclear fusion is in the region of core region, 0.02, 0.23, that is quarter of the radius of the sun, which contains 40% of the total mass of the sun. So most of the mass or the highest density of the sun is near the core region. Importance of solar energy. Very simple. All of you are aware of this. Most basic and inexhaustible source. It is environmentally clean, free of cost, available in adequate quantities, as I have mentioned in the beginning, in almost all parts of the world throughout the year, at least for 3 to 4 hours a day. Solar energy intercepted by the earth is about 1.8 into 10 to the power 11 megawatts. This much amount of energy is received on the surface of the earth. This is 1000 times more than the present energy consumption rate. If we can trap even a single percentage, 1% of this total energy, that is more than sufficient for our energy needs. But still, we are in the developing stage of the technical things behind the conversion. So still it too suffers from the inevitable problems associated with. It is a dilute source. Large collection areas are required because it is most in the form of diffuse radiation. not concentrated. Availability again varies with time and season and the place also. Then storage methods, that is really tough thing. So that's all for this session. The features of solar energy. In the coming class we will discuss about the solar radiation data, some terminology associated with solar radiation plus electromagnetic spectrum will be discussed in the coming class. Till then, goodbye. Thank you for watching. Please do subscribe and enjoy and keep listening. Thank you.